So we're excited to share with you some of the developments and updates, specifically around the Revit and the fabrication side of things. So I've just got a few quick slides that I want to go through with you to start with. It's better. So just with regards to the Revit template, so there's been some really good development over the last 12 months since the last forum. We've had 2 releases of the template since the last Construction Innovation Forum, which has been great. And as you can see up on the screen, some of the key updates I just want to just sort of flag here. It was mentioned earlier today about the E in MEP starting to come and get a bit more momentum. We've had some really good movement with the electrical services. So what I want to highlight is within the actual template file, some of the system families. So as well as the development work that's been going on with the workshops around the content for electrical, for switchboards and VSDs, etc., transformers, which has been going on. Within the actual Revit template, we've been doing a whole lot of work with the cable tray system. So we've basically done an overhaul. We've workshopped and done an overhaul of the cable tray systems and services within the template. As many of you, well, some of you would probably know in Revit, working with cable tray, there are a few limitations with what you can do compared to duct and pipe with systems, and the way it's allocated is just a little bit differently. So we've had to kind of work with what we can do there, but still make it accessible to everyone, for you guys in the industry to use. So in short, we've basically run through and set up the systems for those trays, colouring types, specified all of that information, and that's, on top of that, we've also put these clearance zones. We started bringing these clearance zone capabilities into the cable trays as well. So it's the first progression of it. Our goal is to make it a bit smarter and even work even better, but it's in there now and it's starting to come through. I will mention there as well that PowerCAD have had and the integration of PowerCAD within the BIM-MEPAUS initiative has been great for that push. We've had some being able to workshop that and working with the PowerCAD. And Tim from PowerCAD is, as well as presenting on his own tomorrow, he's also going to be joining us for a workshop that we're doing tomorrow morning, which I'm going to mention a bit later. So you'll be able to ask questions there and get some input on that. Some of the other key things have been alignment to the specifications, the BIM-MEPAUS specifications. So we've reviewed all of the content in the template and bring it more into line with all the work that's being done in the specifications in the background as well. Well, not in the background, in the foreground, really, isn't it? So we're aligning the content now with the specifications and that. So that's been happening. Fitting adjustments and enhancements continuing to develop and update those from the feedback that we get, and also from where the technology goes and allowing us to update that stuff. So there's some of the key updates. With regards to the specifications and the schedules, so with as I mentioned, the development of so many new specifications coming through, we've been able to, through those workshops, the schedules get defined, and so through that, we've actually released today as well as the new templates and the new Revit template in the different versions. We've released a new shared parameter file, which incorporates some of these new schedules and the parameters coming from the specifications, which have come out of those workshops. So that's been good. And I'll point out that, as we said, the E and the P and the F, it's still the approach and the goal is multidiscipline, so we're gathering around that space. Okay. I'll talk a little bit just about the sample model as well. It's been mentioned already. Just to give you a bit of an idea for those of you that don't know, we have a sample model that is downloadable from the website where you get the template from. The sample model, really the main goal of the sample model was, as it says there, for demonstration and for training and for upskilling purposes, okay? So, and even for feedback as well. So for those of you that are perhaps newer to it, you can grab that sample model and you can see examples of the content in action in a real model, okay? There's work to do, we're going to keep evolving it, but it's got example drawings and example documentation, levels of detail of documenting drawings, as well as how the families connect together as well. Demonstrating the view templates and the filters and things as well coming through with the new specified colour systems, etc. And then also workflows is another area that we've been trying to help facilitate for the industry with the new technology that's coming into the software with Fabrication within Revit, driving some of those workflows. Dave's going to be talking a little bit more on that in a sec, but we're trying to basically facilitate those workflows. So with the feedback from the industry, so driven basically from that feedback. So, the key point as well is that the Revit, we've done a lot of work with the Revit families and the Revit template to align with the Fabrication database. So there's a streamlining of translation and a conversion to there. So there's some workflows there. So I want to just finish with 2 points. And the first one would be that, just to reiterate what's kind of already said, all of this sort of development, even over the last 12 months, has been because of mostly all of the feedback from the industry. That's where most of it comes from. Obviously, is the workshops. So yeah, for those of you that have been involved in the workshops, thank you very much. For those of you who might be new to the initiative, come along to our workshop tomorrow morning. So we're having a workshop tomorrow morning. I think it's pretty early. It's like 5:30 a.m. or something. No, 7:30 a.m. tomorrow morning. Yeah. So come along and you can. That's going to be a more informal Q&A. You can ask questions, and if you are new, you can engage. And if you want to get involved, you can get involved. Yeah, I think I'll hand it over to Dave. I think Dave's got a really exciting video demonstration to share with us.
Okay, for it,
So I'll hand it over.
Thanks, Brendan. Thank you. Good afternoon, everyone. Can't see a thing, but good afternoon, I think you're still there. So, yeah, what Brendan's just alluded to, I fly the flag for the fabrication side of the industry and also the manufactured content that is available to download from our website, from BIM-MEPAUS website. So I work closely with the manufacturers, which is all linked in with the initiative, and those that were here this morning listening to Warwick's presentation. The whole concept of the initiative is to align specifications with manufacturers' content so that the data that's in the content is usable throughout the workflow. Interesting to listen to what Malcolm was saying, actually, and actually some of this video that I put together is sort of can be applied to the workflow as also. So rather than doing a lot of talking, because I know some of you struggle with the language barrier because I'm from the UK, but I've put a 5-minute, 20-second video together, called it From an Hour, Shannon, you'll be pleased to hear. But yours had to end up on the cutting room floor. So I'm going to let the video do the talking. It's got some bit of text on there, and then I'll just say a few words afterwards. And if you can roll the video, please. So I hope that gave you a bit of an insight into what's actually available in the industry. There was 5 minutes, 20 seconds. There was 8 solutions in that whole video that's available now in the industry, which can be applied for the whole workflow from design right through to possibly FM. So that's my bit of the section done. I'll pass over to Jason now. Thank you.
Thanks for that, Dave. That was a pretty interesting video from my perspective. I don't think as consultants we get to see what happens after our models get submitted to go out to construction. So my name's Jason Pleaner from Irwinconsult. I'm actually your stand-in today. Unfortunately, my colleague who heads up our MEP section of the office wasn't able to attend today, so you get me, the engineer who knows enough about Revit to be dangerous in the office. Just by way of introduction, Irwinconsult, we're a multidiscipline consultancy firm covering all aspects of building engineering, from structural, civil to the building services, mechanical, fire and hydraulics, as well as some of the specialty fields of waste management and traffic management as well. We've been around for 60 years in Melbourne and about 50 years in our Darwin office with 160 staff also in Melbourne. Our focus is pretty much solely on buildings. We don't really get involved in the infrastructure side of things very much. It's purely a building focused company with a long track record of delivering successful and innovative buildings in both the typical commercial fields as well as pharmaceutical and laboratory fields. So I wanted to talk today a little bit about our sort of journey from first bringing Revit into our office and developing our own in-house template through to the decision to go with the BIM-MEPAUS template and the benefits that has seen in our company. So the Revit template, we started working with Revit in the mechanical, electrical and fire and hydraulic sections probably in about 2009. The structural engineers had been working with it for about 3 years prior to that, but we started a bit later on. Prior to that, it had just been the standard use of AutoCAD for developing our documentation. When we brought Revit into the office, we started off developing our own in-house template. This took an enormous amount of man hours to actually generate all the intricate details that you need in a BIM model, like your ductwork bends and pipework connections and so on and so forth. And I think certainly the impression from people in the office who weren't necessarily on the modelling side was that this was taking an enormous amount of man hours, and is it really worth the hassle? What we also found was that the drawings, certainly at the start, did not look nearly as good as our AutoCAD drawings had looked, so it almost felt like a bit of a step backwards in using our own in-house template. And despite all of the efforts in going to develop our in-house template, what we found, of course, was that the contractors had no use for our 3D model at all, being that it wasn't an industry standard template. The model virtually had to be scrapped and started again once it went to contractors. As you can see on the left-hand side, this was the sort of first iterations of our own in-house template documentation, and it sort of really lacked the detail that where we are now, I guess. So why did we choose to go with the BIM-MEPAUS template? There were really 2 reasons for it. One was a specific project that we were working on at the time kind of drove us to changing, and the second was really that internal requirement for change based on our experience with our own in-house template to date. So The specific project that I'm mentioning is a high-end pharmaceutical client that we do a fair bit of work with. We had the benefit, I guess, of hindsight with this particular case in that we'd already done one large facility project with them. And from that, we had a number of lessons learned that we could then apply to the next project in line. So some of those lessons was that when contractors took our model of that first project and went to develop their own shop drawings and modelling, they really had to, as I mentioned before, scrap our model and start from scratch. This meant an enormous amount of time to develop their own model and consequently the shop drawings, and obviously a lot of cost then that gets handed over to the clients. Our model lacked the detail at the time, particularly when it came to spatial requirements. In a pharmaceutical facility, space allocation is really key, and it's an enormous amount of coordination that goes into layers and layers of ductwork and pipework in a facility. And when our model is looking, I guess, like what you see on the screen here, where there's no valving, the radiuses of bends may not actually be industry standard from our own template. This then translates to what appears to be a coordinated model is not the case in reality once you start adding space for valves and so on. And the client wanted this certainly changed on the next project to minimise that contractor modelling time. We needed a higher degree of consultant coordination and high level of spatial accuracy. And internally, we decided to sort of move away from our own in-house template. I think certainly the engineers, including myself, had enough of really coming up to the drafties who are also sick of hearing from us, asking why these models and these drawings aren't looking as good as they once used to in AutoCAD. So we wanted to bring in an in-house template that was an industry standard that would give a more consistent look to our drawings and our documentation, and at the same time reduce the time and cost to our own draftspeople and modelers, etc., in developing these non-standard templates. So the experience that we had with the template, the first thing that we certainly noticed going from our in-house template to the BIM-MEPAUS template was a significant increase in the improvement in the look and quality of the documentation. So on the left was the first project that we did with this pharmaceutical client, and on the right being where we were with the BIM-MEPAUS template. Much higher degree of spatial accuracy with insulated pipework, valves put onto pretty much all pipework connections. Ductwork had the correct size of dampers and so on and so forth. As mentioned, much higher degree of spatial accuracy. We were able to download very easily from the BMA website, industry standard valves, pipe connections, and various other pieces of equipment, which translated to a far more accurate model, and then ultimately the finished product. Probably one of the biggest advantages that we found was being able to seamlessly transfer our model over to AECOM, who were building this particular facility, or the services in this particular facility. The model was handed over to AECOM, who essentially then took the next steps in developing their shop drawings and fabrication models, etc. There was no need to do a wholesale remodel of the entire facility, which saved a significant amount of time for all concerned. So the particular building, we finished the modelling of that in about December of 2015, and construction of that project began about 3 months later. So shop drawings were rolling over to us within a couple of months of the contracts being awarded to Coombs. And parts of that building are now starting to be handed over today. So I guess in conclusion for us, it was a significant time saver and cost saving for us to move to a standard template, and particularly from the client's perspective, it meant a much faster workflow in getting to shop drawings and ultimately fabrication on site. I'll hand over to my next speaker. Thank you.
Hi everyone, Adam Sheather. I work for AECOM, small consultancy. So I really wanted to be pretty quick and cover some of the new technology that's already out, and I'll just put this forward too. I don't work for Autodesk, even though this is going to be heavy Autodesk product focus. But what I wanted to show is some of the new technology that's now available for yourselves and that we're integrating with our clients that you can build from scratch. So we've heard about the challenges with things like Unity and some of those modeling engines today, but there's solutions that Autodesk now are starting to pull apart their solutions and really offer a kit so that you can reassemble your own kits without having to hire specialist software developers. You can get JavaScript developers off the street with none of this modeling experience. And so we'll talk about a couple of those things. So, and this sort of sample right here, this is completely free. You can go and download all the code and actually pull apart this stuff yourself. So this is that combination, again, where it's not just about looking at a model, or it's not about looking at a chart, or it's not about looking at data. It's about looking all of it and then having it react contextually. When I select things here, the model's updating, the charts are updating. When I'm grabbing properties, things are working with what I'm trying to find. So I don't know if anyone's heard of DirectShape. No? Okay, so DirectShape is it's a new part of Revit. It was introduced about 2 years ago, and the main reason you probably haven't heard of it is it's an API system that sits under the hood. What it actually is it's the Autodesk Shape Manager kernel, which simply put is the Inventor manufacturing kernel that sits in the Inventor product. And so what this started to allow, originally they put this in to better work with things like Rhino and have better interoperability, as people have probably seen over the years, the whole don't ever bring in a CAD data, it's horrible, don't ever bring in anything, we'll just rebuild it. And that still sort of rings true, but what they did when they brought this in is they completely opened it up to allow you to build your own custom import systems and that sort of stuff. So what we've started to work with, we're working with a pump manufacturer in Denmark. Probably some of you have heard of the unicorn guy, as he likes to be known. But one of the things that we've started to working with them is, and this is at a pretty early stage, is STP files. If anyone's heard of STP files, this is like what CATIA uses and Inventor uses. And the underlying file format for STP is the same schema that IFC uses. So IFC was very much the manufacturing, STP was very much the manufacturing. IFC is sort of an expansion in a subset way of focusing more on the building information and structuring those relationships. But what we started doing is, can we take this CATIA model and automatically turn this into a Revit family with, these are pipes and we can get the lengths and we're getting the valve counts and it's not a big dumb object and we're getting the materials across. One of the other things we started doing when we started pulling this apart was starting to look at things like, all of a sudden we had control over swapping certain components out or exposing only the parameters that we want designers to influence. So one of the issues for the manufacturers out there, as they know, is you have to sort of give everything in that Revit family and then hope that people don't break it, which generally happens a lot. So you can really hide all that away and prevent unintended manipulation. So our successes to date have been this type of level, and that's adding all the piping positions and electrical points as well. All Revit components, categories, subcategories, all the materials are put forward. And again, you can see the fidelity on this thing too. What's really nice about this, and I was showing Brendan last night, who was actually quite blown away, is how fast this is actually manipulating, because it is using that totally different solution. And because you've got that control, what we can start to do is limit things. So again, we currently have this process with content where we get this model across and someone has to spend a lot of time going, well, we can't have this piece and we can't have the holes because it's going to be Revit voids in it and that's going to make it really unwieldy. But we're not building geometry off the Revit engine anymore. We're building it on the Inventor engine and simply viewing it in Revit and then allowing users the Revit experience of control, but the Inventor kernel is manipulating. So this really offers a lot of power. And there's still things like you can still have your 2D annotations over the top of this and all those bits and pieces. But while this looks like, oh man, that's going to be clunky, I ended up putting like 700 of these into a Revit file last night on my tiny little laptop, and Brendan's like, oh wow, that's still spinning. So there's a lot of power in this type of content and in the API itself. So and for those who maybe aren't coders, Dynamo has a lot of already exposed nodes like the Sprint node package and things like that. So for those who have got Dynamo guys in the office and just want to start getting their heads around it, there's a lot of exposure already done. So the next thing I wanted to touch on was Forge. Has anyone seen Forge? Heard about Forge? Very little. Forge is an initiative by Autodesk to unlock all their design or various parts of their design tools and expose them as web services that you can recouple all your bits and pieces together. So there's a great example. You can go to the dasher360.com website. And what this is they're building these things. So this is an FM solution. They've got all the live sensor data. These are all the additional sensor points around desks and power units and temperature. This has been running for about 5 years in Toronto, this experiment. But now they've enabled it, and you can look at this on your phone. So again, when we were talking about some of the hurdles with breaking these models up, where the Forge viewer piece of this platform has come is they've really focused on the idea of streaming large data sets. So you can get 300-400 meg models pretty easily streaming on your iPhone with no post-manipulation. You just put the Revit model up. The other one here, this one's a really good one that I don't know why they haven't promoted this, so I'm going to promote it for them. If anyone's seen A360 before, A360 is an area where you can go and load up Revit models, and it's sort of like a Dropbox, I guess. But what it allows you to do is if you place the same models over each other for Revit and Navisworks, it'll instantly bring up this changes panel here. So what you can instantly do is start looking at what's been added, what's been modified, what's been changed. You can break it down by discipline. You can look at transform changes versus addition changes versus property changes. And once you've got the level that you want, and this is really fast, you can hit the download button. You'll get a CSV file of every element that's changed, when an element went from X to Y, and all these bits and pieces. The A360 stuff is free. So it's a much better compare experience to maybe Navisworks if people are used to that, and it's online. So if you need to go to someone else and go, hey, look at this, you copy, you paste the URL, they can open that up and have a look at it. So there's a number of other things like data management and design automation, model deliveries, which do that automatic. When you put the models up, it automatically splits the data apart, splits the geometry apart, and you can recombine that. And again, one of the things we've been talking about with Dave, we've been working with a larger mechanical contractor in the States, is we're using this platform to enhance their fabrication experience. So we've got a database that's effectively separating the data movements. So one of the typical experiences that a lot of people do is they make model in Revit, save out an MAJ file, open it in SMEP, do some stuff there, there's another file. But we're moving that through the APIs directly through the database. So if you want to look at the revision 4 revisions ago, you don't go hunt for a file, you just go, show me that revision. So, and then the other side of that is on site, you can interact with this and go, yes, that's installed, that's about to be installed, that's going to feed back into Revit, guys are going to be able to get updates on, that's about to go to shop or whatnot, so that sort of thing. So, and the last thing that I'm touching on, and I don't know much about it because no one does, and this is still a dream in a sense until we actually see some real results, but Project Quantum was something Autodesk highlighted at AE last year. And the real difference is it sort of spins everything on its head. So at the moment we focus a lot on these files, and the app makes a file and then that file goes somewhere else, or through the cheese grater, as Alice has said. And my impression of what this is really flipping it on its head, where you have a single data source, and various disciplines are merely interacting with the level of data that they need at that time. So, in this example, and it's very focused on facade, so I do apologise. But in this example, you got the engineering analysis stuff isn't concerned with the connection. That's down to the fabricator. You got the architect who's interested in the geometry interfaces. So again, it's really about this idea of if the data's all centrally located, you simply pull out your little bit. I'm not interested in, like Navisworks, you get everything all in one go. And then you have to go and contextualize that experience for people. You set up views and color coding and this sort of stuff. This is the vice versa of that, where the app simply lifts the data that you need, but not only lifts it, but you can then interfere with that data, make geometric changes or solutions. It's version tracking, all this stuff, and it's pulling back into that central data source. So I don't have to go and ask someone, can you send me that model, the latest version, so I can have a look at the differences. The new version pops up, I check the difference between the two, and if I'm happy with it, I accept that change. So again, this is the promise. Hopefully they can get it right. But it's really interesting, and when you look at things like GitHub, which probably people have heard of, it manages data. It doesn't manage files, and what it allows is a developer working in any platform, any language, any software system. They can all work on GitHub. They can all collaborate with each other, and you don't go and go, oh, what's the latest change in that file? You're like, what is the change to the data that has affected my program? And that's the real difference of pulling that context out without all this moving. And as everyone knows, we spend a lot of time moving files at the moment. So this is a great thing for the future, and hopefully it comes through. So I'll leave it at that, guys.
All right. Thanks, guys. That was some great presentations. And just to tie in to what Adam was talking about there, and some of the things to the relevance of this session today. So we wanted to highlight the fact that we've got this vision, this philosophy, this methodology for specifications and standardising on MEP, and how those specifications then translate into the template. The sample model there is for training and development, as Brendan alluded to. Some of the great things that are happening in the fabrication database, and then how the consultants are starting to interact with the template and the workflow down through to contractors. So where Adam's part comes into it is being very much aware of what the opportunities ahead are. So once we've set standards, we've set methodologies around workflows and those types of things that the industries has given us feedback through the workshops and through feedback, through some of our direct feedback links on the website and that type of thing. So then, we've set those things in place, and then how do we move forward? So it's always interesting from our perspective to understand some of the opportunities that are possible now that people may not be aware of, and also where we think we can take the initiative going forward to maintain that relevance to people using it. So just a general or a brief kind of overview there, guys. But if there's any questions from what you've heard today.
Sorry, what was your question?
You create those data using software, so then you need to pass on to the shop drawings and to produce the duct and so on, and then install it. Do they all use the same data set?
Yeah. So through the we have component specification documents that we create. So that's based on an air handling unit as an example. So we focus on one component at a time. We'll get the right people from within industry in a workshop together. So consultants, contractors, suppliers, A2K are there from a technology perspective and how that relates to Revit. And then we'll define the capability, or we understand what the industry needs first through that workshop. And then we look at the standardised data sets that are relevant to the workflow, so from the consultants down to the contractors and through the suppliers as well. The data set grows as it goes down the chain. We also look at what's relevant for FM, commissioning and those types of things. So they're all standardised, and Brendan talked about the shared parameter file. So those shared parameters are the data sets that each component specification, that's what we develop inside that. And then it has to relate to what Revit's capable of from a system and family perspective. So in that sense, it's possible for the consultants to hand over those models to contractors and continue to build on those things. And then our contractors certainly use these models for FM purposes and service operations and things like that.
And a key aspect is to engage with the manufacturers to make sure they're on board and they understand that what the clients require, the FMs require, so the whole workflow is engaged in providing these parameters for the whole industry. It's not just one section of the industry. So we talk to the manufacturers. It'd be nice to have a lot more manufacturers on board, to be honest. You know, if the industry can tell us which manufacturers, or have a dialogue with the manufacturers and say we want to be able to use your content in our models because we need that data, then that will give a lot more gravitas to the whole concept and the whole initiative throughout the industry. So we can work together and collaborate and only improve on what we've got at the moment.
So from your experience, are they ready to be integrated in the whole supply chain? Do you think, are they ready in terms of
the manufacturer? Are the manufacturers ready?
And the contractors?
Yeah.
Yes, I'd say
absolutely.
So, yeah.
So I know some of our members through the AMCA are doing 95% and more of their projects in BIM. So that, you know, and if they don't get the models from some consultants, they'll create their own in BIM or Revit and some of the other packages sometimes, but mostly in Revit. So certainly there's people that are far advanced and certainly ready. One of the things that the BIM-MEPAUS initiative allows is developed by the industry for people looking to start up, and I think Jason's example was a good indication of that.
I'd say
it's out of the box, right?
I'd say
ready
it's
to use.
critical for the workflow to ensure that, certainly even from a designer's perspective, that you're placing objects in a model that are true spatial objects, and that the model is properly coordinated before it's passed on to a contractor. And we need the engagement from the manufacturers to provide that technical data, and then we can ensure, we can sort of quality assure the industry that that content is spatially correct and it's got all the correct technical data in there for the whole workflow to leverage. Even, you know, in the perfect world, even the facilities managers, which is what Malcolm was alluding to earlier on in the previous presentation. You know, the perfect workflow is for the whole industry, including the building owner, to be able to leverage that data. And you know, that would be what I really want to see in this industry.
I think the standardisation at the moment that's been done to date, we've had projects where we've had some of the contractor drafts guys come in and deliver the work to the fabrication level straight away, because there wasn't any point to design it and then fabricate it. It was easier to get them to come in and work on our models for a couple of days, and then that was signed off by the engineer, and then basically they got their own file back. But because it's all standardised, there's no train up and this is how we do things and this is how that, it was just a plan and it was actioned quite successfully.
Yeah, fantastic. I think we've got one up the back there.
My question is directed to Adam. Are you suggesting that manufacturers may be better off creating our models in an inventor platform rather than Revit?
No, I think obviously the manufacturers still generally generate their content in CATIA or Inventor or SolidWorks. They normally start off in some sort of product that's really focused on that. Is there benefits in doing it in Inventor? Possibly, and Autodesk already has some of the workflows. And the reason they were really broken a couple of years ago, because they first came up with this Inventor workflow, but they hadn't yet migrated that kernel inside of Revit. So that kernel movement is a lot better than it was before. But the issue still is there's still a lot of finite control that you really want over these models. So there are things that you don't want in there, and there's things that you want very specially done in Revit. And my issue with the Inventor to Revit tool is it works, but it makes too many assumptions on your behalf at the moment. So with the guys we're working on, I think the ultimate goal in that is to help support them with some sort of tool set that is generating these families for them up to a point. So they simply work in CATIA and then they hit the punch it out to Revit button. And then that content is manufacturer ready. In terms of who does this in the future, like, you know, whether it's a content developer company who builds these tool sets and integrates with these solutions, or whether vendors develop their own, I think that'll be quite mixed. But there's a lot of opportunity just to remove, and for anyone who's developed content, you know, there's a lot of work in pulling apart these CATIA files. You've got to get them in the right format. You spend ages going through it, and then you make a lot of assumptions about what the Revit family should look like. So there's big opportunities there.
Yeah, Rush.
Yeah, so I'm sure that people are interested in the detail inside of fabrication parts. Can you explain to us what Autodesk are doing in regards to making it a little bit easier?
Well, you were in the meeting. They know that there's some drawbacks currently with fabrication in Revit. If you're referring to fabrication in Revit, I presume. Yeah, there's some limitations, but although the conversation went yesterday that that is feasible and you can do that, and I think you made that comment actually, Rush. So that was a curly question, was it? But no, from an old school CAD guy, CAD-MEP guy. Yes, it's not as the functionality is not as good as CAD-MEP. In conversation with Autodesk, they admit that, and they are certainly working hard on providing a better solution for that product in the industry. And I don't think it'll take long, in my opinion, for it to happen. Right. It's just my opinion.
Well, Jeff?
No, you're saying in your presentation there, you're writing that BIM 360 field now has the ability to backtrack and link back into the models and
Yes.
just change the status on the fabrication part.
I've been assured it can change statuses.
That's a comment. Thanks,
I only
Jeff.
learned that 4 days ago, Jeff, I'll be honest with you. Yeah.
Yeah. Look, I think if just a little bit more to add about some of the things we've been doing in terms of development. Yesterday we did have a workshop with a big bunch of people from the industry, contractors and duct fabricators, and Autodesk, and we spoke about some of these things that the industry needs here locally to continue to develop the fabrication database and the workflow to the needs of what the businesses have. And I mean, this fabrication database has been in development for years and years. A lot of investment's gone into it. I mean, I think the videos shows a really great representation of what it can do. But one of the other key things is that we're still looking and discussing and talking to Autodesk about some of the limitations and where we can, how they can fix those to help us, you know, move it in the right direction and improve the functionality and improve the efficiency of it. One of the things we spoke about yesterday is there's a couple of workarounds around some of the dynamic hole function capability and some of the things around the representation of insulation and airway sizes and things like that. So those things we know about. There's workarounds for them. We've discussed those with Autodesk, and they, you know, were very receptive of our feedback, and certainly willing to work with us to help, you know, move it in the right direction. And I will just want to point out too, there is, just by the way, with part of this development, there's a nice little ductwork sample just around the corner here that Kavanagh's have been great to sort of put that together. And it does show some of the standardised components around insulation and ducts and things like that, and how the quality's been improved and progressed a long way throughout this process. So,
Just to add to that, a bit of weight to that, which I can do that. I mean, the old school people in the room, who I know quite a few of you, I mean, we know that CAD-MEP is a mature software. It's been around for 20 years. Fabrication in Revit's only been around for 3 years. However, I know the development team very well, and I've seen the improvements that have been made over the last 3 years, and I believe that it will be a great solution for the whole industry. And I know that the development team are working very hard to bring it up to the same level that CAD-MEP was at. So yeah, I think it's going in very much in the right direction. I believe it is a solution to use now in Revit for duct fabricators and duct fabrication.
Great.
Yeah, just on that one, the AEC collection now is under subscription. You get the CAD MEP bundled in, so it's a real help for those that are in perhaps that AEC space in the consultants area. Now you get to serve the ITMs.
You can do all the drawing for the subbies.
All right, we might probably just one more question.
On the BIM-MEPAUS website, I've seen the air handling specification. I haven't been able to see a generic model as yet. Is there around it?
Yeah, absolutely. So it's on its way. So part of the workshops is we try to define what that generic model needs to look like and how that would work within Revit. And part of Warwick's presentation was around the relationship and partnership with Autodesk in terms of how those industry foundation models get developed, which are the generic models and families. So yes, that's certainly a work in progress, and that's where now this fabrication database, a lot of the development's out the way now. Most of it, we're now looking to put some of our resources and focus on those generic models. So the air handling unit, you've probably picked a pretty good example because it's a very complex, lots of variables to it with lots of different connections, and so it's not an easy one to get on top of. So, but we've been able to define what we need, and yeah, so it's certainly coming.
The generic library for everyone's info you should see it increase over the next sort of 12 months now.
Yep.
For sure.
Yep.
So keep your eye on it. And multidisciplinary.
Yeah, that's all right. So I think, guys, if there's any more questions, if you'd be kind enough just to...
the back there. It's a
up
bit
the
hard to
very
see. The
back.
light's
Yeah,
really... We can't see
much.
like
Oh,
past
probably
four
one
people.
more, yeah.
Can you hear me?
Yeah.
Dave, just what you mentioned before about the...
Oh, hi, Danny.
The Revit fab together compared to CAD-MEP. Going on your experience in the history where you've done shop drawing and CAD, can you give us some sort of time frame or comparison of where you think a Revit shop drawing using fab is now compared to CAD-MEP?
Good question. If you're using MAJ files, don't detail it, just send it to the fabricator to get it made. Move on.
That's not a correct answer.
No, well, I mean, if you come to the workshop tomorrow morning, Andy Robbins will actually be online from the UK. So you can ask him that question direct, I guess.
Well, what are we talking about in terms of efficiencies of shop detailing? Like, are we talking 50% reduction, or is that a fair comment?
Again, if you leverage the power of an MAJ file and you send that to a fabricator who can build straight from that, there's no point in detailing a drawing, in my opinion.
I agree.
Yeah.
I think unfortunately there's a lot of time spent in drawing offices with people over detailing drawings. That's just my opinion. Okay, I know what the industry does in the UK because they've had that ability for a long time. But there are duct fabricators in this country who are more than capable of making from MAJ files, and why put information on a drawing which is unnecessary?
Is Revit fab at the same point as say CAD-MEP and MAJ?
Fabrication?
Yeah.
Yeah.
It is.
Yeah.
So from
Yes.
That'd be confident with that.
Yeah, absolutely. If you don't believe me, ask Andy tomorrow morning.